Okay, so today we're going to learn how to use the distance formula. But before we begin, I think the obvious first step would be to make sure that we are being accompanied by Skippy the Duck, who will be our fearless and reliable guide through the mathematical wasteland that is distance formula usage. And now that that necessary step is taken care of, let's move on. I find it personally helpful to label these points, even if it's just in my mind. So here are 2 points that are being presented to us. We've got 3, 4, and 5, -3. As most of you know by now, each point on the Cartesian coordinate plane is consisting of an x coordinate and a y coordinate. So the 3 in this case corresponds to an x coordinate. The 4 in this case corresponds to a y coordinate. We're going to take this a step further and actually call this first point x1, y1. We're going to then call the other point x2, y2. And if that's not clear why we want to do that, it will be soon. Before we get into the algebraic portion of the problem solving, I'd rather get a visual representation of what's actually happening here and what our goal is. So our first point, once again, x1, y1. Let's actually graph this point. So it's 3, 4. What does that mean for us? Well, here is the x-axis, and here is the y-axis on the Cartesian coordinate plane. The point 3, 4 would suggest us going over 3 units to the right on the x-axis, and then 4 units up. So we're going 1, 2, 3, 4. We're going to draw a nice red dot there, and in fact, we'll be very thorough and label it as well. The other point is 5, -3, which would be a matter of going over 5 units to the right, and then down 3 because of this y coordinate of -3. So we're going down 3, and that would land us right around here. And what are we really doing here with the distance formula? Well, we're imagining that there's a line that would connect these 2 points. And then we're trying to find out what is the length of this line. So to get to it, let's get an idea of, well, what is the distance formula? The distance formula, represented algebraically, consists of this ridiculously huge square root symbol, and in my opinion it's probably a good idea to associate the distance formula with this really large square root symbol as soon as possible. That way you have that association in your mind, and you might find that memorizing it becomes easier. So first thing I do when I write or draw the distance formula is I take care of that. I draw that big square root symbol. And then I do these 2 parentheses because I remember that there will be these 2 quantities happening inside there. I also remember that each of those quantities will be squared and that addition is happening between them. So what is going on inside these quantities? Well, what's going on is we're going to have x2 here and y2 here. And over here we're dealing with x1 and y1. And there's subtraction happening within each of these parentheses. So I've color-coded everything to make it a little bit easier to know what we're associating with what. So I say we go ahead and just fill this in using substitution. Once again, the large square root symbol. I'll take care of the parentheses first. I like to start from the outside in. And what is our x2? Our x2 is 5. And what is our y2? -3. What's our x1? Our x1 is 3. And our y1 is 4. And there is subtraction going on here. I feel like this is required for some reason. So once we've got that substitution in place, then we can actually use math to simplify this situation. So what happens here? We've got 5 minus 3 in parentheses. Well, that ends up being 2 inside those parentheses. So I'm going to keep the 2 in the parentheses, and we are squaring that 2 ultimately. What's going on here? We've got negative 3 minus 4. Well, that would end up being a negative 7. And there is still that exponent of 2 hovering above that negative 7. Putting a border around Skippy now. Okay. So that's what we're dealing with. Let's take it a little step further. We've got 2 squared. Well, we know that that is definitely 4. And we've got negative 7 squared. So negative 7 times negative 7 is a positive 49. So we've got 4 plus 49, simplified further, would give us a 53. Now, it so happens that this 53 cannot be broken down into prime factors, and the reason is because 53 is itself a prime number. So we have a radical 53 going on right now, the square root of 53. If you were to use your calculator, that would end up being some strange decimal. For simplicity's sake, we're just going to leave that as a radical 53. That is, in fact, the answer to this problem. So, let's make sure that we have that represented right here. So that's how we use the distance formula.